Okay, our topic today is going to be solving different types of problems that we've seen so far. Our focus question: what is the difference between a proportional and non-proportional relationship? So our warm-up says, a movie theater sells popcorn in bags of different sizes. The table shows the volume of popcorn and the price of the bag. So here's the volume of popcorn. Here's the price per bag. Complete one column of the table with prices where popcorn is priced at a constant rate. That is, the amount of popcorn is proportional to the price of the bag. Then complete the other column with realistic example prices where the amount of popcorn and price of the bag are not in proportion. So we're going to put our proportional answers here. So if the volume of popcorn is 10 ounces, the price is $6. And we know that proportional relationships, if you double this column here, we're multiplying this times 2, then this column will also be doubled. So from 6 times 2, we're going to get 12 in this column. But now we aren't doubling this one. We're going up by 15, right? So we want to look for some nice numbers here that we can go up by. So I know that in between 20 and 35 is 15. So if I take that $15 and separate that down into fives, so 20, 25, 30, 35, I might be able to find something. So I'm going to go back up here and use the $10 price. If I go half of $10 to 5, then this price over here will also be half. So that'll be 3. So now I can see that every time I go up $5 or 5 ounces, the price goes up $3. So 20 to 25 would be $3 more, and another $3, and another $3. So that's a total of going up $9 altogether. So 12 plus $9 would be $21. Now in this case here, from 35 to 48, that's going up $13. That's not a nice number, right? It's not easily divisible by 5. I can't cut it in half. I can't even cut it in a fourth and have a nice number. So what might be a good strategy here is maybe I can figure out how much 1 ounce of popcorn is. If I figure out what 1 ounce of popcorn is, well, then I can figure out what any number of ounces popcorn is. So if I take 5 and I divide it by 5, that'll give me 1 ounce. And I take 3, I divide it by 5. 3 divided by 5 is 0.6. So 1 ounce is 0.6, or 60 cents. So if I have 48 ounces, 48 ounces times 60 cents is $28.80. And I know this is proportional because there's a constant in proportionality, right? 0.6. 10 times 0.6 is 6. 20 times 0.6 is 12. 35 times 0.6 is 21. 48 times 0.6 is 2180. So over here, it's asking us to make a realistic but not proportional relationship. So if 10 ounces is still $6 and 20 ounces, I don't want it to be $12 because that would be proportional, but maybe we give them a little discount because they're buying more. Maybe we say we give it to them for $10. And if $35, maybe we give them even another discount. Maybe we give it to them for $15. If they buy 48, maybe we give it to them for $20. So there is no constant of proportionality in this column, but these prices could be realistic, right? If you buy 10 ounces, you pay $6. If you buy 48 ounces, you pay $20. So let's do a review of what it means for something to be proportional. If you remember, proportional relationships, they have a constant of proportionality, just like the first column in the popcorn problem. They make a straight line on a graph and they go through the origin, 0.00. And the equation is y equals k times x. Right? Every time we're going up by 1 here, we go up by the same amount over here. We can find the constant of proportionality by dividing, right? 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. So a way to test we have a proportional relationship. So let's move on to 1.2. A state park charges an entrance fee based on the number of people in a vehicle. A car containing 2 people is charged $14. A car containing 4 people is charged $20. And a van containing 8 people is charged $32. So how can we organize this data to make it a little clearer? Well, we're going to make a table. We're going to make a table, and our variables are number of people, and the cost. So we have some information here. 2 people is $14. 4 people is $20. And a van with 8 people in it is $32. So how much do you think a bus containing 30 people would be charged? Well, let's look at this and see if we can see some kind of pattern here. If we double the amount of people, does the cost double? 2 times 2 is 4. 14 times 2 is not 20. Let's look at this one. 4 times 2 is 8. 20 times 2 is not 32. There does not appear to be a proportional relationship here. So there's not a number we can multiply by 2 and by 4 and by 8 to get these values here. We know that 2 times 7 is 14. So if 7 would be a constant of proportionality, 4 times 7 is not 20. So let's see if there's another pattern here, though. So from 14 people to 20 people, it's going up by 6. From 4 people to 8 people, it's going up by 12. Oops. So maybe if there was 3 people here, what might that cost be? If it's going up by 6 here, it's going up by 2 here, It's going up by 2 people, and it's $6 more. So let's say if there was it's going up by 2 people, 6 divided by 2 is $3. Let's see if it's going up by $3 per person. If there was $3 or 3 people, then this could be 17, right? 14 plus $3 more is 17. And then $3 more is 20. So it looks like for every 1 person, we're adding $3. So here we're adding $12 and we're going up 4 people, right? So we're adding 4 people, $3 per person, that's $12 more. So this appears to be that pattern. So if we go up from 8 people to 30 people, that is 22 more people at $3 per person. That's going to be $66 more. So it's going to be $66 more from 32 to right here. So 32 plus $60, I'm sorry, $66 would be $98. Okay, so $98. If a bus is charged $122, how many people do you think it contains? So now we're going up to 122 over here. So how much is the cost going to be here? Well, let's figure out how many dollars is going up, right? 98 to 122, what's that difference? 122 minus 98 is $24. So we're adding $24, right? So if we know that each person is $3, if we're going up $24, 24 divided by 3 is equal to 8. So we're going to add 8 more people. So we have 38 people over here. Okay, question number 3. What rule do you think the state park uses to decide the entrance fee for a vehicle? So we just want to find what the vehicle costs with no people, with 0 people, right? What's the vehicle cost by itself without any people in it? So we can work our way backwards on our table. We can go up to 1 person. And so we're going to go down $3 more, right? We're going to go down 1 person. 14 minus 3 is 11. So 1 person costs $11. If we go to 0 people in the car, we're going to go down another $3, and this is going to give us our car price, $8. So the car price, the total cost is equal to $8 for the car or vehicle plus we have the $3 per person. $3 per person. So what's different about this relationship that's not proportional to a proportional relationship? What's the main difference you notice? Or what are some similarities that you notice? What are some similarities and differences from proportional relationships to non-proportional relationships? So this non-proportional relationship, we can see that it doesn't go through the origin, right? If this is 0, this is not 0 over here. So we have a different starting point. We have a different y-intercept, 0 and 8, where a proportional relationship goes through the origin and has point 0, 0. There is a constant rate of change, right? $3 per person is going up by $3 every time. It also has a constant rate of change. But this doesn't have a constant of proportionality. There's not one number we can multiply by these values to get these values over here. So even though there is a constant rate of change, there's not a constant of proportionality. So let's go to our notes. So some rules that described the non-proportional situations. There was a pattern. It was going up by the same amount. There was no constant of proportionality. There is a constant rate of change. And there's also that additional one-time value added, like the car price, right? There was that additional vehicle price that was added to the cost of admission. And we didn't add that vehicle price every time a person was added to the car. It was just a one-time fee. So what were some strategies used to help solve non-proportional problems? Well, we had to figure out what that additional value was, right? We had to figure out what that price was that we started out with. Making a table was helpful. And also finding the rate of change. What was the cost every time a person was added to that vehicle? How much did the price go up by? So those were important things to remember when solving these non-proportional problems.